All right, so here we're back in Rhino. So we were setting up this at the very beginning, and then we were changing stuff within our rooms and schedules, and it's by far not finished. We also were testing some shading, the influence of shading on the building and so on. It was very interesting. It's all still a bit, there's still questions open, which probably are ideally answered by an engineer. But I think we learned a lot in the last few videos about how to use Honeybee energy. Okay, this is our current script. I'll put things away which we don't need at the moment. So this is our script we're working on, and we have some program construction sets, and we applied some program to different rooms, and then we added windows and so on, and solve all the adjacencies of all the different groups. Yeah, then we were testing how we could use the air conditioning system. I won't use that for now because we are basically replacing parts of what we set up in the programs, and that causes some issues with the output we are looking here on the thermal load balance. In general will clean up a bit. I will just delete whatever we did not, or what we don't use for now. Stuff like this, which is floating around. This one as well. Everything which is not needed. We might keep this. We might need that. It's just some weather data tools, which we might need later. But everything else, let's not bother. Also this one. Let's not use it. There was also some shading. We tested some shading. We keep that. That's all fine. And so basically all this here, or let's say without the weather data, all this until here is building the model, which we then feed into the Honeybee model. Whenever we have this model, then we can start to look at output. And we were able to look at output from this very simple one, this very simple first model, because there are always programs and construction set in place as dummies, as a temporary data information. Now we're here. Last time we looked at the heating, ventilation, air conditioning, and cooling systems. We will check that again later when we get to these results. And let's very quickly jump into simulate whatever's in here. We covered that partly already within the first video, but let's just look at that again very quickly. So from our model we can simulate stuff, but not just that. It actually creates. We actually have this Open Studio software in the background which we could look at. We've done that in one of the first videos, so you could get, if you haven't seen it, maybe you go back and have a look. I will not go into that because this is all about Grasshopper and what we could look at inside Rhino from that model. But yeah, you can even tweak stuff inside the Open Studio app. So this, whatever you feed in here as the model with the weather data and whatever you need, like the simulation parameters, here we just decided, for example, what we want to test and what we want to have within our simulation. Then all this is fed into the Open Studio model, which you then can open in the Open Studio app, and you can find it's written in your output folder. Important here, you have different outputs. This is basically the output in different formats for that Open Studio model, and some of them we can reuse, and some of them are, depending on what tool you want to run afterwards. This is it's crucial to understand. You always get a clue when you then, for example, look at a result and it asks you, it will basically tell you what kind of input it needs. But yeah, that was the Open Studio model. I think this is from the simulate section probably the most important, probably, maybe it depends on what you're testing. If I now open the Honeybee annual loads, this is actually just a very quick run Honeybee. It actually says already, run Honeybee rooms through a quick energy simulation to obtain an estimate of annual heating, cooling, lighting, equipment, and service loads. If I open this, you can see it actually doesn't allow an input of a Honeybee model. You need to input all the rooms, which is a bit strange. So I could go in here and put this in here instead of the model. You can add shades. You also need to add the weather file. I think we looked at that before anyway. But yeah, we can still have a look. North, we assume that the north is correct. Timestamp, let's not care about this. Cooling load, optional load for cooling. That somebody would need to explain me, but let's run that. Need a boolean toggle. Let's see if it actually works. Yes, it works. And then we have some output. Oh, we need to run it, I guess. Yeah, it ran. And now we could go here and look. And now we get a total load, which is the kilowatt hours per square meter for cooling, heating, lighting, and equipment, I guess. So if I would go in here, I would need to see 7.2. We need another tool here, so separate numbers from the values. The header from the values. Let's see. Yes, you can see the output here. Heating would be then the second one. Yes, lighting. Yes, and equipment. Is it equipment? Process, there's nothing in there. Hot water, nothing. There's actually some hot water. And balance. No, there's no balance. So yeah, you get some basic output basically. And I hope I don't forget anything here. But yeah, here you would need to run the balance. Okay, let's do that. So it's basically a very simple, simplified version of what you can get out of the Open Studio calculations here. So it's to get an overview. That's how I understand it. Please correct me if I'm wrong. And then peak loads. It's very similar. Runs also with the rooms, but here we actually don't look at the E plus weather file, but we look at design days, which is basically specific days during the year. I think maybe let's go here. This design day. Yeah, this one actually we need. Sorry. Let's do it, just to make sure we covered everything. I hate my mouse. My mouse doesn't allow for clicking and scrolling at the same time. I can just run this here, and then again I could read this out via panel for each month. Cooling, heating. So just to understand, so you have the annual loads and the peak loads. So just to get a very quick understanding of what's happening in your model, and we can then go further. Just realized I didn't have my camera on. Sorry for that. But okay, so if we continue here, sorry, going back. Now, what are these items here? For example, the Honeybee custom simulation output. This, on how I understand it, is you can filter the output whatever came out of here. So you can actually, when you read over this, create a custom simulation output object by plugging in one or more names of Energy Plus simulation outputs. So these are the Energy Plus simulation outputs, and I could plug in something here and it gives me the report, but I could also be more specific and could check here, could put a text and then filter out exactly what I want to see from that Energy Plus simulation. When we basically created these outputs, the simulation output, we could use that here to determine what we want to see. So we can plug that into the simulation output. That's why it's called the custom simulation output. This is the Honeybee simulation output, which we already discussed before, and this would be a more specified or more customized version of that. Not 100% sure, really. So if I plug this in, for sure it's gonna restart the whole calculation. But yeah, I think it's there to be very, very specific on what you want to check. That's how I understand it. Honeybee shader calculation. Let's not use this. I don't need that for now. I have my output parameters. The solar shadow calculation. This is actually interesting. I can basically define what and how Honeybee or OpenStudio should calculate the shadow, but there is already a default value in here. So the default value is an average over 30 days with full exterior with reflection. That's how the shadow is calculated. When I look into here, I can specify that to be more specific, but you can decide what kind of method you want to use or how accurate, and there are different methods. And here, when you look at number 3, full exterior with reflections, this is already what's anyway calculated. So in a way, this you only need to use if you want to specify the shadow calculation more. For example, if you only want to calculate the shadows inside, and probably then your simulation runs faster and so on. I think it's clear. Simulation control. Again, this is interesting if you want to change the simulation control here. The default is run simulation for the run period, but you could also run it in a different way. You can specify it by putting a true. Probably can run more than one, I'm not sure. Default is true. So if I'm reading here, the simulation control, a simulation control object that describes which types of calculations to run. This can be generated from the HB simulation control component. Default perform a sizing calculation, but only run the simulation for the run period. So you could add more stuff. That's what it's doing, a sizing, zone sizing. When you look here again, perform a sizing calculation, but only run the simulation for the period. For sizing period, here it's false. So this is basically the default values are the same. The output here is the same, but you could change that and add, for example, the for sizing period, which is here false. Again, this is just to show you that there are different options. You can use your simulation parameters. Next one is the one we have already, the simulation parameters. That you need in order to actually run the simulation. That let OpenStudio know what you want to actually run and how. And we saw some of the parameters just now, the shadow and the simulation control. And there is also the sizing parameters. The Honeybee sizing parameters, again, this is something where you can optimize your simulation parameters. For example, when I look here at the design day file, you could, for example, specify an optional path to the DDY file on your system, which contains information about the design days used to size the HVAC system. If none, Honeybee will look for a design day file next to the EPW and extract all the. So basically, it already takes that into account. It's if you want to specify it differently or with a different file, then this becomes very handy. Again, it's like to modify or to more customize your simulation parameter. I'm not an expert on these things, please. I'm just helping you to put these scripts together. Just keep that in mind. Okay, so then the next thing is load measure. Measure path, load measure. I have no clue, but let's just examine what's in here. I know that there's a measures input. Load OpenStudio measures into Grasshopper and assign the measures input arguments. The resulting measure object can be plugged into the measures input of the Honeybee model to OSM component in order to be included in the export of OpenStudio. Read more about OpenStudio measures and creating your own here. So, okay, if I would like to examine it a bit more, I could double click here. Just let's very quickly check it out. OpenStudio Measure Writer's Reference Guide. This OpenStudio Measure Writer's Reference Guide is an in-depth resource regarding the authoring, testing, and distribution of OpenStudio measures. The primary purpose of an OpenStudio measure are to inspect and optionally make some change, addition to the OpenStudio model, validate model input, and report model input and output. Okay, if you want to learn more just read this. I will not go for that. This is way too much for a video like this. I mean, again, you could study these things for years, I guess. But yeah, so there's an optional input for measures which can alterate on how you want to output your model. I guess that's all I can say to this. And then there's more here. Run the OpenStudio workflow, run IDF, run Honeybee IDF, and run Honeybee OSM. This has something to do with the interoperability between OpenStudio and Honeybee Energy Plus. So I could go here and run this. So I could input here the OpenStudio workflow and an E plus weather file, and there's more to it. Translate. I think this is you need to set to true, so it will all translates all the JSON information into a IDF output. And what's the point of all this is basically if I want to then run, I want to run basically all this here through Energy Plus. As you know, that Energy Plus did not allow me to actually use the Honeybee model, but it seems like that with this tool I can run then the whole, at least here I can run the IDF file. Oh, sorry, here, IDF. I'm getting confused because here's an IDF output. Maybe that's already enough. But I could run this and I get an Energy Plus report, for example, as an HTML file or as an SQL file, and so on. And there is another tool, it's called Run OSM. I'm not sure if there's then any difference really in the output, because it shouldn't. So again, I can run the OpenStudio model through, or do I need to take this one? Not sure. Because I'm already using the E plus weather. So this is all a bit confusing and I don't want to test it now. It takes me too long. It feels like that. Why do I need this tool in between? But maybe I needed to translate whatever is in here so I can properly run this through E plus and get a report out. So you can check it out at home. I won't bother with it because we want to look at other stuff. But yeah, maybe I'm missing something. Maybe I'm missing out here. But yeah, again, you can test it. Let's get rid of this. And maybe we need that later on again. I'm not sure. But let's look at that stuff. That seems way more interesting for now. The end use intensity. Here, this is similar to what we already outputted in the past. But yeah, let's go through one by one. SQL, I have an output here. I could put this in here. And it seems like I don't need to, yeah, here you can change the units. Total end use intensity result from simulation. Specifically, this is the sum of all electricity, fuel, district heating, cooling, divided by the gross floor area. The value will be in kilowatt hours per square meter if IP is false or none, kBTU per square feet if true. Okay. Basically gives you the final kilowatt hours. Can I add a panel here? Per square meter, by the way, per square meter for the whole year. Ah, here it's shown again. Yes. Okay. So I could have this next to each other. Heating, cooling, interior lighting, electric equipment, fan systems, pumps, heating, rejection. And we have the gross floor area. From there you could, for example, then calculate your area per square meter. Well, this is already square meter. We could calculate the entire kilowatt per hours for the entire building. Total gross floor area for energy model. This can be used to compute the total energy use from the intensity values above, or it can be used to help with other result post-processing. The value will be in square meter and so on. So I hope you get it. So this square meter of all the rooms, and this is just the ID or the item. Then we have the total kilowatt hours per square meter. I can multiply that and have the total output. So I could take this and multiply and then this would be my total output, annual output. Next here, custom results. Here this is very similar. It's just that I can plug in my SQL output and then just type the name on what I want to see in the result. Cooling, heating, and so on. Nothing special here. Read phase result. It's calculating. Okay, that was calculating some more stuff. Phase indoor temperature, and I guess this is gonna be per phase again. So if we want to color our Honeybee faces, let's get this here. That would be the model again. So we could place this. Running a bit out of space here, but yeah. So we have my outdoor temperature, indoor temperature, sorry. Phase indoor temperature, phase outdoor temperature, and phase energy flow. Interesting. So let's have a look. We need the model, legend parameters. Probably we can phase, and this is the data, and then we should actually see something. I will turn this off just in case. Yeah. The outdoor temperature. This is the indoor temperature. You can see average indoor temperature. Very interesting. Can add the outdoor temperature and also the energy flow, of course. Interesting. This is very useful. Phase energy flow would be interesting to understand a bit more how that affects everything. Of course, they are much higher with the windows. But for example, why is this less than this, and so on? It would be very interesting. Data collection for the heat loss or heat gain for each building surface. I understand. Total surface average phase conduction heat transfer. So that's actually what I'm gaining. The energy I'm gaining, and here what I'm losing. It's not 100% clear, to be honest. Data collection for the heat loss negative or heat gain positive through each building surface. Probably. So this is actually what I'm gaining on the kilowatt hours per square meter, I guess, through sunlight. And now it's debatable if this blue is this one or that one. Probably less here on top and more on the side. Probably. But yeah, I think it's very interesting to also see not just the usage or the balance, but also the heat gain. What else is here? Read HVAC sizing. So the HVAC sizing, again, that was a problem when we attached our any of these systems. Then we basically, it interfered with the system already in place through the program of the different rooms, and that causes some issues with these outputs here. Then you can see that crashed completely. There's a problem because the heating and cooling doesn't work. If I disconnect this heating and cooling, then it works again. And here also, because it doesn't understand the output. But I still get the heating, ventilation, air conditioning, cooling, sizing output with this tool. HVAC sizing, please don't ask me, really. It goes a bit too far in terms of what the boundary of my knowledge. It's outside the boundary of my knowledge. I would probably study that in much more detail on how these systems work, but my understanding is that it helps you to figure out how to size your heating and cooling system or air conditioned system based on the program, based on based on all the information we get out of the Open Studio model. But that's really all I can tell you at that point. So you get the zone peak cooling, a list of numbers for peak cooling load of each zone on the summer design day. This corresponds to the zone names above. And I guess these are the component types which are currently in place. And I tested if it makes a difference if I add here a different air conditioned system. It doesn't really change the output here. So I'm guessing this is a tool to understand how to size my air condition and heating cooling system. That's a very high level overview, and you really need to. So if this is important, and it is for sure, it's a very important topic, because you want to, if you planning a building and you want to get the heating and cooling system right, then of course you need to understand how big that unit needs to be. Yeah, for sure this is a difficult task. In this building where I live, they had loads of problems with the heating, the water heating, the heating system, because they didn't size it properly to the actual amount of people living here. So I think it's a very important topic, but I can't really expand more because it's outside the boundary of my knowledge, really. But yeah, if somebody of you has more understanding of these items and want to engage more, please write your thoughts or links to websites where we can read about it in a simple way to get an overview, and then if we're interested or somebody's interested can then read a bit more about it. For sure there's loads of information out there, but yeah, I can't cover everything. If you have a very specific question after this like main series, then we can go into a more specific items probably. Let's check the next one. I think today we just try to finish these here, and then we can look more in all the others. We covered basically the Honeybee color faces and Honeybee color rooms that we did already. This is basically just the output, a color output. We did the thermal load balance in the past, which is this one. This is all really just to illustrate, and maybe next video we can do these so it doesn't get too long. Read room comfort result. Interesting. Okay, this is another type which we could actually, this is very interesting. That's what interests me most. Hoppala, got it out here. And we can use that again with, instead of feeding the data from here, we can get this date this time. So I turn off the color faces, and we can now look at operative temperature for each room, data, and enable pre. Okay, so these are the temperatures. Actually not so much difference, 1 degree difference. Air temperature, here it's more in the kitchen. The kitchen is very red. It's because we have a very specific program. We did a very customized program and construction set in here. That's why it's much different than the others. And the others, they only have this typical apartment program, and that's why it's so different. But radiation temperature, let's see. I guess this also depends on where the room is located. Relative humidity, that's also interesting. Okay, here is more, there's less in the rooms above. Again, in the kitchen is more. I guess, again, because of the construction set and the very specific program we put into the kitchen. It's also good to see that the more specific you are with your program, the more realistic it becomes, I guess, on what the output is or the result is. Okay, we're almost there. What else? Read room energy result. And this is what we did already. So this is basically reading the kilowatt hours for each of the rooms. And then what we did here, we divided it monthly. So we get a monthly output. Combined with that monthly chart, we get this. Okay, I think that's it for today. And the next time we can look at this stuff here. Read zone sizing again. This is normalized by floor area. Yeah, we look at this, and then probably we also look at that here, because there's more stuff to understand. There's also UTCI for the outdoor areas. That's I'm very interested in, and I hope we can have a very clear understanding of that as well. So again, these few tools next time, and the thermal map, PMV comfort, adaptive comfort, UTCI, read thermal matrix, visualize thermal map. Yes. All right. I hope it was not super confusing, but it's very straightforward, really. It's you always just take a tool and then look what's the input and what the output, and that gives you a clue on how to use it. Really, that's how I do it most of the time, because it becomes more and more abstract for me, where I really just can guess what that all means and what we actually trying to understand here and what we trying to analyze or calculate. So this one, I'll save that. Yeah, I hope this was not completely confusing now for you. It definitely becomes super abstract for me. What does it all really mean? And for sure, if you have a better insight as an engineer who does that for a living, then you have a very clear understanding now, I guess. And maybe with your knowledge and Grasshopper together, it becomes your new superpower. Have fun, and the next time we look at the final few tools which are left, and then we are pretty much done. And maybe do a live stream as a conclusion, and maybe people can they can prepare some questions and ask, and maybe I can do like a live tutorial, maybe one whole model in one stream or something like that. I don't know yet. Again, if you want to become a member and support my channel, please check out my channel page and join. See you next time.